Okay, so this is the Carpenter DRA Working Group meeting for September 11th, 2025. I think let's go ahead and get started then. Um, Pulling up the agenda, I don't have it up quite yet. Lima, is there anything else other than your topic yet?
No. I think it's just my thing. Unless
Okay,
you got anything.
not yet. Um, Most of my time this past week has been working on helping getting node overlay out. So that'll be
Gotcha.
great because that will unblock us on the node overlay integration, but yeah, haven't been able to make much progress on anything else.
hmm yeah, that sounds good. Let me share my screen. Okay, I sent this in the Slack, but I think the last two meetings we were talking about how for the E2E tests, Carpenter uses Quark, but we wanted obviously to work with DRA, and then this existing DRA Quark driver it doesn't work for us because they do it with like cluster loader, like for the scale testing, which isn't the same for Carpenter. So I wanted to go over what I was thinking and kind of what you were telling me last meeting. And then if you had any comments, I could just like, I want to just go over the overview before I flesh out any specific details.
Mhm.
But I think the main things is that basically, let's see. Yeah, the basic idea is that we have a config map that maps the node selectors, which would have like the labels and any taints or affinities, and it would map it with the actual resource, the different resource slices associated with that node. And then in the tests, when we do create a fake no or like, the simulated node, um, I'm thinking like we have a watch where whenever there's a new node being created from the test, we actually like compare with the config map and then get the resource slices. And then with like our created DRA Quark driver or like the controller, we would actually create the resource slices. Um, yeah. And then also with some tests creating like DRA pods or resource claims requesting those, we would request it from this controller.
So what do you mean by request from this controller? Uh,
Like if some tests are gonna ask like have pods, like DRA enabled pods with resource claims.
yeah, so I guess in this case, well, resource slices don't actually track any state, right? All of
hmm
the state is being tracked, well, in Kubernetes tracked by kube scheduler, and then in Carpenter, it's obviously going to be tracked by Carpenter. So hopefully that means that this can be relatively stateless in that, like, we're just creating the resource slices when the node is created and then deleting them when it's deleted. And then as far as like Carpenter, like the Carpenter under test is concerned, we don't need to be concerned about what is creating the resource slices. From our point of view, it could be like this Quack driver, or it could be like a real driver. So in this case, we're kind of using it to mock a real driver. Like we could create resource slices that look the exact same as what is created by NVIDIA's DRA driver, and it should be able to work.
Okay, I thought I thought with this we're also not only creating like this config map, but we're also creating this. Oh, so you're saying that we basically call the drivers to create the resource slices that our config map has, but the only thing we're creating is a config map.
Well, so based on the config map, I think the way you had described it earlier made sense to me, which was we have our config map. It has node selectors associated with resource slices. This controller then sees whenever a node joins the cluster that matches that node selector, it creates one or more resource slices for that node based on whatever's in the config map. and then deletes them when it's gone. But I think that's like we shouldn't need any, and maybe I misunderstood you, but we shouldn't need any communication, I think, between Carpenter and this controller.
Oh, I see. Okay.
So because all we care about is that it's creating and deleting, yeah, creating and deleting the resource slices along with the node. And then Carpenter, for its part, doesn't care what is creating the resource slices. It just cares that a resource slice is created that matches the shape that it expects.
Okay, okay. Um, that makes sense. Um, I think the thing was for this case was that I was trying to think about like our tests that we made for our first PR where we don't schedule like a
Mhm.
pod with resource claims, like a DRA enabled pod. We're not doing that. So then I was thinking about how to use this for those tests. And then for that, I was thinking, um,
Okay, I think I might have misunderstood what you were saying then. I think just to make sure we're on the same page is what I described as far as the functionality of the controller, what you were thinking.
yeah, for sure.
Okay.
But in terms of communication between Carpenter and the controller, like if we have a test, s- like think about the that first PR where
Mhm.
um we wrote those tests. If I were to use this Carpenter DRA clock driver for that test, for example, would I not have that communication between like the scheduler?
Well, so I guess my point is that in this case, what's the best way to word it? Carpenter is not responsible for actually scheduling the node. So I believe we don't need any form of actual communication with the driver itself to like make it fake doing the actual allocation of resources. As far as making Cube Scheduler actually do the binding of the node based on the resource slices that are available, my understanding is that it shouldn't need to do anything other than create a resource slice of the correct shape. Like it shouldn't need to communicate anything back to the scheduler. Um, there are some like feature gates that are available for DRA. I can't remember what stage they're in, but where you can actually communicate some information about like allocation status over I can't remember if it's kubelet communicating that over the resource slice or I think on the resource claim status. Um, but I
Okay.
think for initial support, we don't need to worry about implementing that.
Okay, that makes sense. But eventually we will have like quack tests that will have like that'll extend beyond just creating the resource slices.
So I don't think as far as this controller goes, it needs to do anything more than that.
Okay.
Carpenter is going to do like as far as any updates to the resource claims, those should be made by Kube Scheduler. And Kube Scheduler, for its part, shouldn't necessarily care what's creating the resource slice as long as the resource slice is created. And the resource slice is largely a stateless object.
Okay.
I can't remember off the top of my head if it's entirely stateless, but I'm pretty sure it is. So it's not expecting the driver to be making any updates to the resource slice. The resource slice is kind of just this structured piece of data that the scheduler can use all of the state on it to determine where it can bind a pod to. Now, we might need to do some additional things. Like I said, if we wanted to build testing for, like I said, I can't remember the name of the cap off the top of my head, but there was that feature for basically allowing the driver to inject itself into the allocation decision. I can't recall exactly what that was though.
Okay.
But that's
Okay.
something-
I I
that's
think
a
that
bridge I think we can cross when we get there.
okay.
And for what it's worth, we may not even need um, that type of testing in Carpenter, um, because from Carpenter's perspective, it doesn't necessarily care about the transient state. It just cares about, did we create a node that will get us eventually to our steady state of things being scheduled. I need
Mhm.
to look more into the feature though. I don't know enough about the implementation details of it off the top of my head.
Okay. Okay, this makes sense. Thank you. Wait, I'm gonna edit this probably right after this, and then I'll just ping you. And if you could leave more comments, but in yeah, I think let's just start with that, and then
Okay, yeah, sounds good.
I think that makes sense. One last thing. Like, can you give an example of like a simple test that we would want to use this for, where it would just create, yeah, like do you have an example of a like a test case where we would use this
Sure. I mean, so
kind of go
let's
over
just say
that flow? Because I think it's hard, like I understand the general idea of like how we want to create the resource slice, but I just can't even think of a specific use case.
yeah, let's say we basically want to do some like mock quack tests where we're I mean, it could be some arbitrary device type, but to give a real world analogy, let's say we're mocking the NVIDIA driver. So we create a resource slice for like an H100 GPU, and that resource slice then has all of the attributes that we would expect to be associated with an H100 GPU. And then as part of our test, we create a resource claim that's selecting on those attributes. What we would expect to see is that um, Carpenter, because like with the node overlay integration, would know that, okay, um, this instance type should have a resource slice of this shape. It should then be able to look at the resource claim that's associated with the pod and do that match. And then eventually we would expect to see Carpenter bring up that node. In this case, it brings up a Quark node. Then this controller would react to that, bring up the resource slice, and then we would expect Kube Scheduler to go ahead and actually bind the pod to the node. And then that is then like the end condition of our test is that we create a node, we created the right node, and based on that, the pod schedules, and we can use the pod scheduling as like our correctness assertion. And the nice thing about doing it this way is that it basically serves as a conformance test with Kube Scheduler. We believe a resource slice should like we believe that something should schedule against a resource slice of the shape. So we create a node, we create that resource slice, and then as long as Kube Scheduler can successfully bind the node, we know we're in conformance, or bind the pod to the node.
Sure.
Yeah, which conformance is going to be especially important given that we largely have to re-implement allocation. So we're definitely going to want to have a pretty broad conformance test suite.
Okay. Okay, this makes sense. And then again, the reason why there's no communication between like this controller that we're creating and Carpenter is just because like once we create the resource slices, it's just available to be found. Like it's
Yeah,
not like the controller needs to do anything.
yeah, when I say there's no communication, I just mean like Carpenter's never going to make like a gRPC call to
Yeah.
this.
Okay.
Um, or like a fake kubelet's never going to need to call out to it either. We just need it to create the resource slice. Once it's there on the API server, both Kube Scheduler and Carpenter can see it. So there's like that indirect communication of this created a resource that's on the API server that everything else can see. But or available via the API server.
Okay. Okay, awesome. That clears up a lot.
Yeah.
Um,
I do think the one other thing we'd probably want to see in this is just like an example of what the config map would look like.
okay.
Um, but yeah, other than that, I think
Uh,
it's looking good. And maybe also details about how we had discussed last week, like there basically being two potential modes, one where you provide the config map and another where it just looks at the node overlays. So, and it can basically use the node overlay to construct the same information that you'd be using for the from the config map. I do think it's valuable to have both because we're going to want to have tests where nodes are bringing up resource slices that Carpenter wasn't previously aware of, both to test how Carpenter interacts with existing capacity on the cluster. Like, let's say you have multiple things managing nodes in your cluster, like both cluster autoscaler and Carpenter, or more commonly in EKS, like people will have some managed node groups along with Carpenter. We want to make sure that it respects resource slices that are published both by its own nodes and by existing nodes.
mhm.
Um, but I think we also just want the ease of configuration of we have to create this node overlay object to inform Carpenter of the resource slices that will be created for a given instance type. So
Mhm.
we should be able to just reconcile off that and know immediately. Of
Mhm.
course, the shape of like the node overlay API is still a little up in the air. So I wouldn't worry about like giving an example, but it would be good to just have a discussion of like
Yeah,
this is a
just
feature that we
how
want to
yes.
have.
When is the node overlay integration gonna come out?
So we're trying to get the actual feature merged soon, like within the next couple of weeks. But and it's pretty close to getting merged. Once that is merged and finalized, we should be able to get a pretty good idea of what the node overlay integration looks like.
Okay.
Sorry, the DRA integration into node overlay.
Uh-huh. Okay, cool. Thanks so much. That was all for me. Yeah.
Okay, yeah, I'm happy to sync up more offline if you have any questions.
Yeah, I should. I kind of. Sometimes I wait till Thursday, but I realize I should maybe start asking you to sync up mo more outside of the scheduled working group meetings. Um,
Yeah, feel free to. I don't know for sure if I'll what my availability will look like, but I'm sure we can figure something out. Um, yeah, I mean, minimally we can talk over just over Slack. So,
okay. Anything on your end?
not to for today. Yeah, like I said, I've been a little bit swamped trying to help get both node overlay and our static capacity support out. So once those are both out, I should have a lot more time to dedicate to this. So, because I am still hoping that we should have an MVP implementation by November,
Okay.
and I really don't want us to slip on that. So,
I think we'll also have more forces, Mark, and then on your end, Garvin.
mhm.
Yeah.
Okay.
Mhm. Mark, did you have anything? I know it's like your first time coming, but
Yeah, I think I have a lot of questions, but I need a little bit of time to process them before I ask them. So
uh-huh.
nothing right now.
Yeah. We usually I there's like a Slack group, so I'll add you to it and then you should feel free to add all your things.
Okay.
And I think it would be good practice for me to try to answer them first and then people can correct me after that.
Yeah, go for it. Yeah, I guess if there's nothing else, we can probably end a little bit early today.
Okay.
Yeah,
Sounds
yeah,
good.
thanks
I'll
for
see you
doing
on
this.
the. Bye bye.
Yeah.
Bye.